Hi, welcome to today's CMP 201 Software Engineering 1, Lecture 23, UML Interaction Diagram. Today we are going to introduce important UML models. We have seen the two most important UML models, which is use case model and class model. Today we are going to talk about the UML's interaction diagrams. It's going to record in detail how objects interact with to perform a task. And additionally, by the way, the use case model describes the task which the system must help to perform, and the class model describes the classes to be implemented and the relationship between them. Interaction is just like how these objects interact with each other. And we have the sequential diagram, we have the collaboration diagram, and the activity diagram, which are sub-topics of the interaction diagram. So the collaboration is the objects to link to perform a task. We have the objects, links, and the actors. Objects is just the rectangular here, and each is a label rectangular, which is this is very important. Is name, comma, type. In this case, is the name is called the book, and the type is comma, a column, a book, okay? And the link between the objects are shown like associations in the class model is very the same, yeah. And the thing is the actor can be shown as a use case diagram, just like this cute performer. And the interaction on a collaboration diagram with each label, the arrow represents a message to be sent from. In these cases, we have the copy, borrow, the copy, and the OK to borrow, and borrowed, which is just how this message are passed in between each objects. And the target object must understood this message. That is. And then we're going to see the sequential, the sequential diagram are applicable for modeling the real-time interaction system, And for example, in this case, the same scenario can be modeled as a member, a book borrow the copy, and the library member tells OK to borrow, and to borrow that the copy, and we're going to do a subroutine which is 2.1 borrowed. The copy is borrowed from the book, and here, this is called a use case. This is called a use case, and this is called a use case. This is a use case, and these are just the workflow, and this is the life. No. This is the computation. This rectangular is the computation of the object, and this dashed line here is the lifeline or lifeline of the object. And the sequence diagram shows the object and actors which take part in the collaboration at the top of the dash, and the vertical dimension of the sequential represents the time, right? The vertical represents the time. And the horizontal dimension represents the different objects or roles that participate in particular interactive sequence. So object's lifetime is shown as the narrow vertical part. Yeah, this is it's the computation time, and this is the lifetime. And the thing is that when we are going to talk about the delete, is that we are going to stop the lifeline of the object, but the computation time is here. It will limited within this rectangular. Okay, and then we are going to talk about the as time goes by, time is assumed to pass from the top to the bottom, and the message between objects are shown to be the solid down arrows, and returns as shown as a solid with the solid line. The message between objects and the returns are the dashed line. Okay, if we actively do something, it is a solid line, and what if we return something? It is dashed line. And the task Here we are going to find all the parts of the classes that can be communicated directly with each other. So for example, look that the resource manager is not a class, okay? It's only the UI, the workers, and the skill level to be a class. Therefore, we have the UI find worker with the parameter name to worker class, and the UI has a method to skill class is to find the skill by name. We find the skill with the parameter name, and the UI class can have interaction with the skill level class, where the worker does maybe it's like assign a skill to comma the worker and skill level, right? Therefore, this is the method signature and the direct communication between these classes. And then we are going to talk about the messages from object to itself. Is that an object may frequently does send a message to itself. For example, the object calls another method on itself, right? Using the keyword this. And on collaboration diagram, on a collaboration, you show a link from an object to itself, and the message passed along is linked in a usual way. And the sequential diagram will show an arrow back to itself. That's like OK to borrow. Yeah, this is an arrow pointing back to itself, and this is also an arrow. This is association and the arrow pointing back to itself. Okay. Then we are going to talk about the supporting detailed behavior. It is often sensible to describe interaction at a higher level rather than showing every message between every pair of objects. To do this, we define a full sub-collaboration of collaboration. The collaboration is a collection of objects and links between them. So we define a full sub-collaboration of collaboration. The collaboration is a collection of objects and links between them. The sub-collaboration is a set of the objects together to. Yeah, this is a complex collaboration, and this is a sub collaboration, and this we can replace them with a package, right? And then we can create and delete objects. The sort of the objects involved in the interaction not always static. The object can be created and deleted during the interaction. So in the collaboration mode, we can show which objects are created and destroyed using the new and destroyed, right? The new thing is new. To create the thing, we just destroy it. And it's in the collaboration diagram. And what if in the sequence diagram we can just create a object by an object box, and the destruction we just put it X. So in this case, the destroy will get destroyed, and the new director of study will have a new here, okay? And the example sequence diagram, in this case, we are going to in this case, the object is generated, and in general is created at this point, and this object is destroyed at this point. And this is just how the computation is started, okay? And the timing. The major advantage of the sequence diagram or collaboration diagram is the ability to represent the passage of time globally, graphically. This is the main advantage of sequence diagram, because the time is always flowing from the top to the bottom. And so far we let the diagram only the relative ordering. We let the diagram only indicate the relative ordering, but sometimes time is very important. Therefore, in these cases, where we have this, this is like it's a delayed operation, because when we are borrowed is the actual get the book, and borrowed is this time, and borrowed prime is this time. So we wanted to the moment I request to borrow a book and the moment I get this book should be like within a second. Therefore, it's just indicate the time of the process or workflow. And the activity diagram describes how the items are coordinated. An activity diagram may be used like an interaction diagram to show how an operation could be implemented. An activity diagram is particularly useful when you know that your operation has to achieve a number of different things, and you want to model the associated dependency between them, and you can decide what order to do them. The activity diagram is much better showing this clearly in the other. The activity diagram is basically better than showing the dependency between each other, right? And the number of different, if you know that we are going to do a number of different things, yeah. And the activity diagram, just keep in mind that it's good for dependency. And we use cases must be completed before other things begin. According to this, we can use an activity diagram. And the activity diagram are recording the dependency which are parallel, which are sequential. The UML activity diagram are it's like a state diagram. The reason why it's a state diagram is the state diagram is just this is start state, this is end state, and we have the different state of the system. And the activity, we have the activity, we have the transaction, we have the synchronization mark, we have the decision diamond, we have the stop and the start and stop makers. So in an activity diagram, activity is recorded like a notation of a state. However, as we do not have the transaction as a result of the event, rather as finishing that activity. And it's just after that it's finishing that activity. And activity edge is from after we finish this activity, where can we go? The synchronization part is what if we have the maybe concurrency? How can we do that, right? And how can we? We must wait both of them to finish before we move on, right? And the decision diagram is just like the if condition statement, and the stop and start maker are used to just like the state diagram. And in this case, we have it's also a state activity diagram of a library, where we have the member and the librarian. With the number, it can start a thing that we go to let's say go to see a librarian, and the member can have two types. The first type is a borrower, and second type is a returner. Okay, the borrower can find the book on the shelf, and the we can just go to library to find the book on the shelf, right? And then we can wait in the queue. Both the returner and the borrower can wait in the queue, and then we have seen the synchronization bar, and the next one is going to wait is the member. It is a member. We are waiting for a member here, and a customer is here. Then we can do the transaction, right? And then we are going to, what if it is returning? We go to here, we return the record, and we put it back in. This is concurrency, right? After that, we need to go to another synchronization bar to make sure both are returned, and going to prepare for next customer. And what if we are borrowing? We are just record the borrowing, and that's it. And it is also a synchronization bar because one of it is going back going back to the end, and another thing is going back to the start. Yeah, it's just like a concurrency, right? And the activity diagram, the state diagram, the difference between the activity diagram and state diagram is that the activity diagrams do not often include events. It only includes activities, and the activity diagram do not is intended to process following the flow. Yeah, the activity that's just like the flow of the activities described without the getting stuck. And this is usually one of the goals of the edge living should be satisfied. And we have some the diamonds, decision diamonds to do the gassing. And concurrence activities can be modeled using the synchronization bar notation. Therefore, in this lecture, we have talked about the collaboration diagram and the interaction on them. And we have also studied some sequential diagram to represent the passage of time graphically and time constraints that may be imposed on them. Thank you very much. Welcome the comments and like and subscriptions.